Hello, in this video let us solve this question which was asked in JEE Main, a physics question. In connection with the circuit shown below, the value of current flowing through 2 kilo ohm resistor is dash into 10 to the power of minus 4 ampere. You are given this circuit. This question was asked in JEE Main 24th February 2021 shift 1. So this is a question giving the circuit diagram in which there is a Zener diode. A Zener diode should operate in reverse biased mode. Reverse biased mode means what? P-type semiconductor should be connected to negative of the battery and N-type semiconductor should be connected to positive of the battery. So this Zener diode here, no, this is Zener diode. This is the Zener diode. I just show it. Zener diode that operates in reverse biased mode. Okay, reverse biased mode. So we will see how to do this problem. The 5 volt which is given here, this 5 volt, that is Zener breakdown voltage, VZ, represented as VZ. It is called Zener breakdown voltage, which is equal to 5 volt. It characterizes the Zener diode which is given in the circuit. That is Zener breakdown voltage is 5 volt. So before we proceed to do this problem, we will have to check whether the diode which is shown here is in the on state or off state. Then only we can easily proceed. So how to check whether the diode is in the on state or off state? For that, you remove the diode, that is Zener diode, from the circuit and measure the voltage across the open circuit after removing the Zener diode. So we will check it now. Check the state. That is Zener diode in the circuit is in the on state or off state. So on state means the voltage across this 2 kilo ohm resistance is the Zener breakdown voltage. Okay. What do you mean by on state? Voltage across this 2 kilo ohm or voltage across the open circuit after removing this. If it is greater than Zener breakdown, then we can say it is in the on state, otherwise off state. Greater or equal to, okay, greater than or equal to this 5 volt, that is voltage across the open circuit after removing this diode. If it turns out to be greater than or equal to this Zener breakdown voltage 5 volt, then we say the diode here is in the on state. When the diode is in the on state, then voltage across this 2 kilo ohm will be equal to the Zener breakdown voltage. They are in parallel. Okay. So circuit diagram I am drawing, rough one, because it's a hand drawn diagram. Okay. So this is the circuit after removing the Zener diode. We have to find the voltage across this. If that voltage represented as V greater than or equal to VZ, then we say the Zener diode is in the on state. Okay. Okay, that is voltage here in the open circuit will be equal to the voltage here. For that, I into RL, you call this as RL. I means current here. So I is E by 10 by R1 plus R2 if you want. 3 into 10 power 3 multiplied by this 2. So this is I, just Ohm's law, I into R. Of course this RL, but for understanding purpose I can write I and R so that you can easily connect it with Ohm's law. Okay. So this is the voltage across this open circuit. Simplify this. So 20 by 3 volt, roughly 6.6 or 6.7 volt, whereas Zener volt is, or Zener breakdown voltage is 5 volt. Therefore, we can say that the Zener diode is in the on state. On state. On state means what is the advantage? The breakdown voltage is the voltage across 2 ohm. Then use Ohm's law, find the current through 2 kilo ohm. I draw this diagram again. Okay. Battery 2 kilo ohm. So our aim is to find IL. You know V0 equal to VZ is equal to 5 volt. Okay. Right? V0 is equal to VZ is equal to 5 volt. Then use Ohm's law to find IL. Which is -3, but in the question it is given as a multiple of 10 power -4. So you rewrite this as, compare it with the end of the question, we get 25 should be filled in this gap. So the answer is 25. Okay, thank you.